Hello everyone, my name is Simon Gregorian, and today I'm going to talk about the Lab 3 calibration of a melting point apparatus. I'm going to start off by talking about how intermolecular forces affect the melting point of the substance, talk about how to set a melt station, what equipment to use, and how to use it, and finish off by talking about the lab and how to results the lab in real world and where it could be used. So there are four types of intermolecular forces: ion dipole, hydrogen bonding, dipole-dipole, dispersion forces. Ion dipole being the strongest intermolecular force and London dispersion forces being the weakest. One major factor that impacts the melting point of the compound is the type of intermolecular forces that exist within the compound. What is a melting point? Melting point of a compound is the temperature at which the solid phase transitions into a liquid phase at a standard pressure of 1 atm. For example, in our lab, we use three different types of substances, being diphenylamine, benzoic acid, 3,5-dinitrobenzoic acid, with each one having different melting points. Diphenylamine at 54 Celsius, benzoic acid at 122.5 Celsius, 3,5-dinitrobenzoic acid at 205 Celsius. What this tells us is if a compound has stronger intermolecular forces, then the melting point of the substance will be much higher than the other ones. To be able to find the melting point of the substances, you will be familiarized with a Virion-Go direct melt station. Each melting point apparatus has spots for at least 3 melting point capillaries. Before you start your experiment, it is very important to make sure you record the ID number of the melt station being used. Although all of the machines should give the exact same number for pure substances, human error and mechanical errors must be expected. An error of 0.5 or plus or minus 0.5 Celsius is okay. Refer back to Lab 3 handout to check out your literature values. Packing the capillaries is also a very important step. Not packing the substance correctly in the capillary tubes can cause the substance to melt in different temperature. Place the substance on a watch glass with an open end of the capillary tube. Scoop up the substance into the tube. Turn the capillary tube back around and tap gently with a glass rod on the open end to send the substance down to the bottom. Look for about 2 millimeters of substance resting on the bottom of the tube. Place your substance in the melt station and increase the temperature about 2 Celsius every minute. It is important not to increase the temperature too quickly because your substance will burn. Record when you see the substance melt and compare answers with literature values. The closer your substances are to literature values, the more pure your substance is. In our lab, we tested diphenylamine at 53.4, beginning to melt at 53.4 Celsius and ending to melt at 53.9 Celsius, benzoic acid at 122.9 Celsius and ending at 123.3 Celsius, 3,5-dinitrobenzoic acid at 205.4 Celsius and ending to melt at 206.3 Celsius. Using these values, you can see if your values are narrow and reproducible, and we do that by graphing the calibration curve. Gives us the R squared value that tells us how close our measurements were between 0 and 1. So the closer to 1, the perfect you are. In the lab, you will also required to find the melting point of an unknown substance. This is a mixture of diphenylamine, which we recorded our substance to have a melting point between 49.7 through 50.9 Celsius. This shows us that the unknown substance has a greater melting point than diphenylamine. Experiments like this are very important and are used throughout daily life. For instance, metal workers can figure out the metal used in different types of construction to see if the metal can handle the project. Thank you.